My friends are so stupid! But the incident we have just seen represents one of the most beautiful part of Combinatorics, the Pigeonhole Principle, also known as the box principle. The main idea behind this principle is very simple, but you can't imagine how cool and wonderful it is. The basic law of this principle is very easy to understand. It states that if k number of pigeons enters into h number of holes, and if k is greater than h, then there will be a hole having at least 2 pigeons. We can easily understand it from an incident just happened. There were k number of chairs and we were k plus 1 number of students. So let's try to disprove it. Since Pigeonhole Principle states that there will be a chair having at least 2 students, so for contradiction we would tell that no chair would contain more than 1 student. If we keep placing a student in each chair, then we would see that every chair would be filled up but still 1 student is left, thus we would get a chair having at least 2 students. And if the number of students is greater than that, you can easily understand the rest. Thus, we are done. Now this principle has an advanced version which is more useful, and it states that if d number of balls is placed into b number of boxes, then there will be a box containing at least the ceiling function of d over b number of balls. Don't worry, I'm explaining the value of this expression. We would just have to remember how we did the divisions in our childhood. When we were dividing d by b, we would get an integer quotient c and a remainder r. So thus, d equals divisor b into quotient c plus remainder r. We know that this remainder is greater or equals to 0 and less than the divisor b. Now we have 2 cases for that. If r equals 0, then the ceiling function of d over b equals c, and if r is greater than 0, then it's equal to c plus 1. Now we are going to prove the second one first. So let's apply the contradiction again. Every box would contain maximum c number of balls. So if we keep putting c number of balls in each of b boxes, we would get c into b number of balls in the boxes. But there is still r number of balls left. And since r is greater than 0, so we would have to put at least 1 ball in the box and get our required box having c plus 1 number of balls. Now we would look at the first case where remainder is 0. So now d equals b into c, where principle states that a box would contain at least c number of balls. If we walk through the same way of contradiction by putting c minus 1 number of balls in each boxes, a simple calculation would tell us that still b number of balls are left to be boxed, proving our last step. So now we have learned the concepts of Pigeonhole Principle. We can use it in solving a lot of problems, and you can't imagine how amazingly it can work. Happy counting!